difference. Here's what we're going to do. We're tacking on what we've been doing, where we've been graphing systems of inequalities. Now what we're going to do is we're going to take these systems of inequalities, and we will have, in addition to all these inequalities, we will have a function that we want to optimize. Does anybody know what optimize means? It'll actually be a function of x and y, so it will look like this. And so maybe it's some, no way. What?
I was so confused, like, I was like, we haven't done this yet. I was like, I did.
Wait, what grade did you mentor to?
We did that in Algebra 1, though.
Okay, so means to find a maximum or minimum. It's maximizing or minimizing. So here's what we're going to do in a nutshell, and I think it's easier for me just to show you kind of what we're going to do, and then we'll work through. I'd rather work through the word problems than the ones that just give you the equations, because y'all struggle with the word problems the most and setting the equations up. So we have this, let's say I went through and graphed this system of inequalities. And let's say it looked something like this. And this was my feasible region. Okay. We talked a little bit about the vertices of the feasible region. Those are going to be critical now, okay? Because those are the points that I'm going to use to try to maximize or minimize my function. So what I'll do is I'll graph this system of inequalities, and then I'll take each vertex and I will plug it into my function to be optimized to see which one gives me the highest and which one gives me the lowest value. This will make sense whenever we put it in context. But like for instance, if this vertex was, let's say this was 1, 2. Let's say this was 3, 5. And let's say this was 5, 2. I would take each one of those and I would plug it into my function that I'm optimizing. Okay? Normally I'm trying to maximize profit or minimize cost, things like that within a business. And I would plug each one into this equation. So f of 1, 2 would be 2 times 1 plus 3 times 2, which would be 2 plus 6, which would be 8, right? So the value of the function at this point would be 8. And I do that for each one. At 3, 5, I would plug in 3. And I would plug in 5 to get 6 plus 15, or 21. Same thing at 5, 2. So that you have to come up with that equation. That equation, it will be like how you find out how much money you made. So maybe it's what you sell each product for added together, and the inequalities are taking into account you can't spend over this on remember those word problems we were doing. And we're going to do several of these together, but right now I just wanted to show you kind of what we're going to be doing so you see. So if I was trying to maximize this function, I would say that the maximum would occur, the function has a maximum value of 21 at 3, 5. Does that make sense? And it has a minimum value of what? 8 at 1, 2. Okay? So what I'm building on is I'm taking this system, now I'm finding these vertices, and if you go back and look at some of those ones that I put on Classroom yesterday, I found a lot of those vertices for you and kind of put some notes on there on how you do that. But we're going to go through it today. And so you're going to find each one of those vertices and then plug it into the function there. So let me show you exactly what I'm talking about. Let's do one. I guess we can do one that's not a word problem, and then we'll jump into word problems. Just so before. All right, so let's say, so I don't need this screen. Let's say you have the system of inequalities that looks like, let me move my, let's go here, hello, Why is it not moving? There it goes. Here and here. All right, let's say my inequalities. My system of inequalities are, we'll get this one straight out of the book, I think. Y is between 3 and 6 inclusive. Y is less than or equal to 3x plus 12. And Y is less than or equal to 2x plus 6. I'm actually going to move this down. You know me.
Well, when we're doing this, will always be bounded.
No, it will not always be bounded, but you're still looking at the vertices when you do it. And then my function to optimize will be, you don't graph this. When you see f of xy, you're not graphing that. That's your function that you're plugging into, okay? So as far as these first 3 inequalities, that is exactly what you're used to doing already. Okay, so I need to find the feasible region. Yeah. Okay, so when you're between 2 numbers on y, those are horizontal lines. So you just draw a horizontal line at 3 and a horizontal at 6, and it's in between the 2. Right, right.
That's going to be split.
So if it's like x in the middle,
Yeah.
it'll be up, like that?
Yes, yes. Yes, and you're exactly right. If you split it up and you said y is greater than or equal to 3, it would be from 3 up. And then if you said y is less than or equal to 6, it would be from 6 down. So the combined part there, the shared part, would be in the middle. Yeah.
Do we have to do this graphing? Can I not plug this in my calculator?
You're going to have to graph it to find those vertices.
I can get vertices in my calculator.
You can hit intersection.
I don't know, but I have like a little spider thing. I can like move it to the vertices.
But unless you actually calculate it, it might not give you the exact, yeah. Yeah.
Since the, did we shade it up and down?
Yeah, so if you're between 2, I think this is what Goldie was asking just now. If you're between 2 values like that, if it's between y, then it's horizontal 1, 2, 3. So this is a horizontal between 3 and 6.
Yeah.
And so the shading would happen, it would occur in the middle of those 2. Okay.
So that's how we do the first one?
That's the first one, yes.
Wait, don't leave it.
Okay. No, I'm not shading yet because I don't want to confuse you on the shading, but the shading would be in the middle there. If you need to shade it to see, go ahead. I'll shade it. I'll shade it.
Shoot, I should be using colors right now.
Yeah.
I don't have colors. It's okay.
All right. Luke, you good? Can I move forward? All right. The second equation, I will do an orange. Ooh, I don't like orange next to purple.
Do you not have a 12?
I do pink.
Just do it by 2.
No, you can't do that now.
Now 12's fine. I have enough room.
12, and instead of going up 3 over 1, I'm going to go backwards so I got enough room to do it here. I'm going to go down 3 and left 1.
I do that all the time.
That's fine as long as you make sure your slope is positive at the end there.
At the very top of my paper.
This one I'm shading which direction? Down. Down, down, baby, down. One more. You took her ruler?
When she left and left it on her table, so
2x plus 6. So here, that's going to be an easy intersection point because it intersects right there on the line. 6, and then I go up 2 over 1. And I'm going to connect those. Is everybody with me on this?
wait, which one are you on? There we go. 6.
The last one, yeah.
6. And then 2. No, give me that back. Give me that back. I'm gonna steal
All right,
it.
and this one I shade down again, right?
I literally need to draw this line.
Oh, wait, let's make this -2, so we'll have a nice little feasible region.
I'm already done.
I don't have a nice bounded feasible region with this.
That's not good.
I'm done grinding.
Let's just do the body. It's the same thing.
It's not the same look.
Oh, it goes.
Yo, can I please use that?
Yes, I can just exit. I guess I can just erase it.
That way it's a better example.
I'll just erase it.
Just erase it.
I can't erase.
That's big fat tough.
Oh wait, y'all don't have.
Y'all are some complainers.
And you know what? See, that's why I didn't use color.
I did it with pencil.
I did with pencil.
All right, and this one's down.
Yeah, I'm complaining too much.
This is two.
Luke, you got the whole squad, bud.
Now look.
Is it this?
It's that little triangle.
It's like a trapezoid.
Wait, where? Which one is it? Because I didn't use different colors. So
All right, so look.
Should have used the.
Oh, it's that thing?
What?
Dude, I don't know.
I thought it was like a little.
The little triangle above doesn't have any green in it. Green.
See, the way that I ended up doing it, it was like my point was 0, 6, 0, 3, and then
Big camera too.
like negative 1.
Wait, that's a feasible range.
Just take one.
So all you changed it was a -2.
Yes, I just changed the slope there to go the other way. That's all.
That's a lot of verses.
I call her.
So I got 4 vertices, but keep it right there. All right. But look, here's where, yeah.
It's going to be so
Yeah,
time consuming
yeah.
plugging all these verses.
All right, so look, you have to learn to use what you got to help you.
How to do
And look what I have. The equation of this line is y equals 3, right?
Yeah,
What's the equation of this line?
like you said.
That means every point on those lines has the y coordinate of 3 or the y coordinate of 6, right?
Yeah. Right.
So all I really have to do is look at these lines, plug in 6 for y on this and find out what x is. Plug in 3 for y on the pink one to find out what x. You see what I'm saying? Okay, because I know whatever this coordinate is, it's going to be something 6. It's going to be something 3. Same thing here. Something 3, something 6. So as I find these points, keep that in mind. Sometimes I will go through here, especially if I don't have colored pencils or anything and I've not color coded my stuff, and I will label. This is actually the line y equals 3x plus 12. The blue line is actually the line, what is
It's the
the
negative
is that
2x,
the-
isn't
It's negative 2x plus 6.
it? Ew.
Okay, so looking at this one, let's look at this first point. Is everybody with me before I start this? I don't want y'all to still be coloring and stuff. All right, let me just pause and wait. So I might look at this and think that I can tell exactly what that x value is, but really you want to use your equation because you want to make sure. Especially some of the ones I was doing yesterday on that packet for y'all, they were like point something, 0.2 whenever I'd plug it in. So you want to make sure that you're doing the right thing. So look, several of you keep saying, why is it blank? Why is it blank? We need to calculate them, right? This is sitting on the pink line. So this is the equation. I know the y value is 6.
Yeah.
So if y is 6, what is x? Add 12.
18, 6. No, yeah, 6.
Which one are we doing first?
This one. So this is, yeah, plus 12 would be 18 and then divided by 3. Oh, I didn't see the plus, yeah. Sorry.
Maybe 9.
So it'd be negative. I'd have seen that whenever I went to plot it.
18.
So it'd be negative 2.
Yeah. I'll look at them graph on the other not looking.
And you'd recognize that, yeah, for sure. All right, so -2.
You guessed that one.
You could have. All right, so one vertex
Zeros and that.
is -2, 6. Yeah. You might remember whenever we were doing the intersection of lines and we were solving the system by graphing, and it wasn't always exactly there. That's why, so we can make sure we got it right.
So wait, I don't understand how you're plugging it in. Are you like?
So this line is actually 3x plus 12, right? If I know that y is 6, because this is the line y equals 6, then I plug 6 in for y and solve it for x. Now I'll do the same thing, but I'll plug 3 in for y. So 3 equals 3x plus 12. -9 equals 3x, so what is x there? -3.
But what if you don't always know why?
Then you'd have to solve it like a system. Or put it in your calculator and do calculate intersect, which I think is what you were trying to do. Remember, you're not graphing inequalities on your calculator, but an inequality is just the line and then shading. So if you graph the line and you calculate where they intersect, you can find that point. Yeah. You won't always have them. All right, so I have another vertex, -3, 3. Now I'm switching equations. Do you see why? Okay.
Yeah.
So now the purple or the blue, whatever color that is. All right, so here I need to know when y is 6, if it's -2x plus 6, what is x? It'd be 0. Oh, it is on the axis, isn't it? All right, so 0 equals -2x, so x is 0. So another vertex here would be 0, 6. One more, y'all do the last one. See what you come up
Okay,
with.
I see 1.5.
Every vertex,
I see
that x value. Say it again.
smallest number.
We'll find both. We'll find the max and the min. Yeah, depending on what it asks you.
Okay, so it'd be 3 No. Wait, what is the difference in that one and the other one?
Remember, it's like a trapezoid, so it's coming out. They're not at the same.
Write down.
Can you change it to 1.5?
You can. I hope you all got 3 halves, 1.5, or 1.5 for that x coordinate. So I'm not done. Okay? You see how cumulative this question is? This one question encompasses almost everything we did in chapter 1.
Yeah.
I mean, it's solving systems of equations graphically, it's graphing inequalities. Now we're going to plug, I mean, it's everything. Yeah. Well, you're going to divide by -2.
Oh, I get it.
All right, so now comes the new stuff. All right, none of this has been new yet, right? We've done all this. You might not have calculated the intersections all together when we've done this, but it's not a new concept, right? We've solved systems. So now, what I want to do is I want to take this function to be optimized, and I want to find the maximum and minimum values of the function. So, right, so now I don't even need the graph anymore. I've got these 4 points, 4 vertices, and that's what I'm going to use to evaluate my function, okay? So 4 times, and you'll need to show each one to show that you understand. I got to find each one before I can find out which one's the biggest and which one's the smallest.
You can give us a lot of those on the-
No, you can't have a lot. They take forever.
Okay, this one take me so long.
It takes a long time, yeah.
Yeah, this thing like.
Yeah,
So can we just have one problem for homework?
I gotta give you a little more than one.
One of these.
All right.
This is all it is.
So let's say these two groups, y'all do negative 2, 6. That, oh, y'all already did it? Y'all already did it? Okay, okay, y'all are capable of plugging that in? That's an easy plug, okay. Okay, Mark said go, do it, okay. Look.
King Luke got the classroom.
How did you grade your stuff through?
What'd you get for negative 2, 6? Negative 20. What did you get for negative 3, 3? What?
12.
Negative 12?
Negative 18. I'm sorry.
Wait, for which one?
All right, 4 times negative 3 is negative 12. Minus 6 is negative 18. How about 0, 6? Negative 12. How about 3 halves and 3? Is it? Nice. What is the maximum value of the function? What? 0 is the maximum value. Where does it occur? 3 halves 3, or 1 1/2 3. All right. So listen, because this is the way it's going to be asked on your test. What is the maximum value of the function?
The maximum value is 0.
The max value is 0.
Found that 3 over 2, 3.
Correct. Where does the maximum value occur?
3 over 2, 3.
3 over 2, 3. Where does the minimum value occur? Negative 2, 6.
You write like that. You just say.
Yes. We're going to do an interpretive type one, though. Yours will be a word problem, so let's do one.
So you say the maximum and then you.
A landscape, this is not in your book, so if you need a couple, if you need to jot down whatever you need to jot down for it so you can remember. All right, a landscaping company has crews who mow lawns, and prune shrubbery. The company schedules 1 hour for mowing jobs. I don't know how y'all work word problems, but I always, even whenever I've got the problem in front of me, I do this. And I pull out the pertinent information so I don't have to reread the problem 150 times as I get through.
1 hour for mowing.
1 hour for mowing, and now I lost my place. 3 hours for pruning.
Like trimming.
Like hedges, yeah. Trimming hedges.
Name one with hedges.
Each crew is scheduled for no more than 2 pruning jobs per day.
Oh. Wow.
Each crew's schedule, but it doesn't restrict mowing.
Okay. Oh.
Each crew's schedule is set up for a maximum of 9 hours per day.
On just pruning?
No, altogether.
I thought you said that mowing wasn't restricted.
It's not. Well, I guess it would be restricted if you, it really is. It really is, yeah. All right, on average, the charge for mowing a lawn is $40. And the charge for pruning shrubbery is $120. At what value will the income that the crew receives be maximized? In other words, how many prunes and how many mows do they need to do to maximize their profit?
Exactly.
Okay, so here's what I need to think. I'm maximizing what? How much I make, right?
Yeah.
That's going to be, what they're asking me to maximize or minimize, that's going to be my f of xy. So how do I find how much money I bring in?
By doing all these problems.
That's a lot, but I'm saying this is the easiest formula to come up with usually. If I'm going to let mow be x and I'm going to let prune be y.
Okay.
How do you determine how much you make? 40x. $40 for every mow you do, plus 120y. Oh dear.
drawing the graph now.
Thank you, Dylan. 120y.
That was such a fun thing.
Okay. Do we all see how to do that? Look at what they're asking you to maximize or minimize and write your function first. A lot of times that's the easiest. Now let's look, Now let's look at our restraints. What kind of criteria do we have that we can or can't do?
We only do 9 hours a day.
Okay, so
And it takes 3 hours to prove.
It
And 1
take-
hour to look.
okay, so how can I say that?
I don't know.
X plus.
All right, what is X?
Mowing.
Mowing. What is Y?
Pruning.
Pruning.
Oh, X plus 3y.
All right, let me ask you this. When you set this up, this is number of pruning jobs, right? So you're right, Goldie. I'm going to have to say X plus 3y because every pruning job is 3 hours, right?
Yeah.
So I've either got to account for that in this function or this equation.
It has
or
to be
inequality.
less than or equal to 9.
9.
Okay, so total hours less than or equal to 9. Are we
You
all in
did it
agreement
again.
there? Oh my goodness. Not the only restriction that I have.
You got you got 2 prunes a day, is that what it is?
2 prunes a day, but really it's between, okay, prune is my Y, right? I can't do less than 0, right? This is where my first quadrant comes in. So I'm really between 0 and,
It's greater than 0 and less than 2.
okay, no wait.
Or where
What
you
is
put
my Y in? My Y is in prune jobs, that's right. So between 0 and 2.
Yeah.
You're right, all right?
Y 2 again. Oh, 2
Yep. All right, so Dylan made a good point earlier because I said mowing's not restricted, but he said, well, actually it is, and he's right because if your hours per day are restricted, your pruning must also be, your mowing must also be restricted. So how many mowing jobs are possible in a day? Up to 9 mowing jobs, right? So I can do from 0 to 9 mowing jobs. Does that make sense to everybody in here? Okay, so now it's just a matter of graph the restraints, okay? So you're looking at what all's keeping me from, what all is restricting in the problem, and then I'm going to use those vertices.
So now it's the same thing instead of getting that.
Yeah.
And that's, yeah. Because they can only do 2 pruning jobs a day.
Yeah, no more than 2 pruning jobs in a day.
Because it said that.
Yeah, he did say.
All right. Now comes the tedious part.
I mean, it's the easier part though. I just hate
It's the
math.
part you already know.
Yeah.
It's nothing new. The hardest part to me on this is setting up the inequalities in the function. Okay? You got to reason through. It's a lot of reasoning. All right. Let me set my graph up here.
First quadrant.
First quadrant, I'm just going to stay first quadrant because this is, my X and my Y are both
I'm gonna go like 12.
bigger than 0. I'm going to go white this time, I think. All right. What time do we get out of here today, y'all?
11:45.
Okay.
Y'all come watch Luke run the 400 with me.
All right. X, it's always a good habit to label your axes. So my Y was prunes. And my X was mow. So let's do it. Let's see. Huh?
Will we get points off for not doing that?
No.
Yeah, she did. Miss Leon was expecting like 20,000.
All right. My prunes are between 0 and what? 9? No.
I'll start with the X plus 3 line.
0 and 2?
Yeah.
I think I'll go by 2s here
You got a 0 and you got a 9.
so you can really see.
You said going by 2.
That's by ones.
I meant every other one. I'd said it wrong. I'm going to go by halves.
Oh, I know what you're saying.
Otherwise, I'm going to be in a teeny little box right here. I'll do it so I don't confuse y'all.
I know what you're saying.
You're gonna like win.
I don't have enough room for it though, so I'm gonna do it.
Okay, that's fine.
So you go by what? Once?
That's 2. I'm going by ones. I just went back to ones.
Are you
All
on the
right.
Y or the X right now?
That's the y equals, that's the horizontal line. So that's y is between 0 and 2. And I need x between what?
I'm gonna need colors.
0 and 9. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I know I'm in this rectangle right now, right? All right, tell me my hardest equation there that I had to graph. What was it? X plus 3y is what? Less than or equal to 9, right? All right. That means my x-intercept is 9, and my y-intercept is 3.
Because
X equals 9, 3y equals 9. Yeah, cover up. You with me now, Luke? That doesn't look, that's not a look that looks like you're with me. So if I graph this line, I do x equals 9, and then I do 3y equals 9, and find the intercepts there. Cover up. If you graph this line,
wait, are you not shading it? You're not shading
so you do x equals 9, and then you do 3y equals 9, so y equals 3. Those are the two intercepts.
Yeah.
If you would like to put it in slope intercept form, go ahead.
I like that one better.
I do. All right, that one is shaded below, which means my feasible region is this funny little shape right here.
Oh no.
I got it.
Did I just do
All right, how many vertices do you see? Easy vertex. Easy vertex. Oh, no, that's not a vertex. I'm sorry. Easy vertex. Easy vertex. This is the only vertex that's kind of difficult.
Oh, wait, I didn't even do that.
Right? All right, let's look. We have that's from one of the constraints I made earlier. Yep. All right, 0, 0, 0, 2. What is this one? 9, 0. This is the only one I'm going to really have to think about. Okay? This is the line. This is the line x plus 3y equals 9. And this is the line y equals 2. So I'm looking, yeah.
Whenever you do, well, I put that equation in slope intercept, and then you get like, the slope is -1.3.
Mm-hmm.
You go
From the intercept, down 1
over.
and over 3. Yeah,
Okay. Does that work?
that works.
Okay.
So now my question is, if I've got the line x plus 3y equals 9 and y equals 2, how do you find the x coordinate? I know the y coordinate. How do you find the x coordinate? Plug in the y and find. I solved the system of equations, right? Substitution is the easiest here because y is already by itself. So x plus 3 times 2 equals 9. It's 3. So what are the coordinates of that vertex? 3, 2. All right. I have not yet answered the question that I was asked to start with. The question that I was asked to start with was how many mows and how many prunes should I do in a day in order to maximize the amount of money that I bring in? Right? And so I came up with this function, and it was, what was it, 40x? 40x plus 120y. So I need to take each one of these vertices, and I need to plug it in this formula. So let's see, 0, 0, 0, 2, 3, 2, and 9, 0. So for each one of these, I'm doing 40 times x plus 120 times y. No.
It's a tie.
It's a tie? You are correct. There is a tie. All right, what did you get for 0, 2?
0, 2 is 240.
How about 3, 2?
3, 2, I have
360.
it.
And then 360.
Uh-huh. So I got 0, 240, 360, 360. Now, I need to interpret what this means. The most money I can make in a day is how much? $360. And I can get that one of two ways. How do I get that?
Either do it in non-mowing jobs, or 3 mowing jobs and 2
Exactly. I can do 9 mowing jobs, or I can do 3 mowing jobs and 2 printing jobs. Either way will make me the same amount of money, but that's the most I can make. Yeah.
Wait, did you do 0, 3? Because for 0, 3, I got 360.
No, 0, 2, not 0, 3. 0, 3 is not in,
Oh, okay.
you see,
What
that's,
about if these equations, instead of being inclusive or exclusive?
these won't be exclusive like that.
So there's,
What if
These
it's
will
like,
be
I can't
inclusive.
make, what if they're like, I can't do like more than this, or has to be less than this. Then it would be exclusive, wouldn't it?
If it said it's got to be less than, if it's not less than or equal to, yes.
What if it's not?